Well, good evening and welcome to Space Oddities. Thank you so much for being here. If this is your first time, thank you so much for being here. We were a bit low on the ground in terms of numbers tonight. I'm joined this evening by Roger. How are you, Roger?
I'm fine.
Good, good. Lovely image behind you. I take it that's one of you. Oh, that's the one I saw earlier on Facebook, wasn't it?
Spoiler alert, yes.
Yeah, spoiler alert, yes. And Roger's prints are available.
They are.
How
did that happen?
I'm sure if you want to cross Roger's palm with silver or gold, he'll accept that for these fantastic astro images that he does. And it's a lovely one. Can you just move your head slightly from side to side so we can see what's behind you? Yeah, there we are. That's great.
Wow.
You'll see it. You'll see it later.
Yeah, it's a lovely shot, Roger.
I'm trying to give Kevin Earp a bit of a competition, but I fell because it was too cloudy last night.
Game on.
Yeah.
Roger, can you move a bit more? Actually,
can you just get down again like you were before?
Yeah, that's much better.
That's it. And just stay there.
Go to the kitchen. Go to the kitchen.
That's lovely. It's a lovely Orion Nebula and the Running Man Nebula. And well done, Roger. Anyway. So welcome, Roger. I'm also joined by the illustrious Bernard. How are you, Bernard?
Good evening, folks. Yeah, I'm doing fine. Thanks. I'm not going to move around to show this beautiful picture of Jupiter in the back. I'm just going to stay here.
And Bernard has had 2 books published so far, and his books are available from Amazon.
Thank you. And I've recently, I'm in discussion with my editor for more books to come out. So watch this space, folks.
Fantastic. No pun intended. So Bernard wrote his first book was called The Ocean Worlds of the Solar System, which was a wonderful read. And the second one was called Imaging the Solar System. No,
that's correct. I'm focused.
I've got it on the shelf in front of me. I just can't be bothered to get up and look at it.
Oh, that's fine.
So Bernard's books are highly recommended, published by Springer, and they're so interesting. Anyway, I'm also joined by Daz, who has an obsession with Bruce Willis. So a little known fact. So this is Daz. How are you? And Bruce, how are you getting on?
I'm fine, thank you very much. And when I was talking about Bruce Willis, I was just trying to burst Bernard's bubble. His man.
Yeah,
but anyway,
go. Honest, a bit darker than that, didn't it, Daz?
I'm just talking about Bernard. I was fascinated by the solar display you went to with your daughter too in Swindon. That was obviously one of the old engine sheds or something that you were in. It was a beautiful model of the sun there. Is it done by the same chap who done the moon and Mars?
It's nice that you asked me that, because I'm going to do a presentation tonight on this amazing exhibition that shows the sun in 3D. So let's come back on.
I'll wait till then. I'll wait till then.
Yeah, we'll look forward to that later.
Yeah.
So only 4 of us Space Oddities tonight. The others can't join us for various reasons. It happens. I'm afraid the lovely Rachel isn't with us tonight, so there'll be no gallery tonight. Those of you who've sent images in, apologies for that, but of course they will be on next week's show as always. We do always try to fit your images onto the next available show, but without Rachel we can't do much, because she holds the knowledge on how to do all that, which she does beautifully, of course. So if you're out there, Rachel, we hope to see you soon. But I think you're out with a school thing tonight. So there we are. On a packed show tonight. Well, not quite so packed this week. We have, of course, Roger's Sky Guide. We have finally news of our February competition, where you can win a lovely prize, viewers. And in fact, it's 2 prizes this month. So I'll be talking about that very shortly. And also we've got the news section. We'll be chatting about what's in the news and other odds and ends as well. So let's talk a little about the prize. So as you may know, thanks to the generosity of our sponsors, Rother Valley Optics, we are able to offer a prize every month for a competition. And so far the competitions have been successful with lots of people entering. and we've had great fun doing them. And it's always lovely to give prizes to people, of course. So this month's prize is this. Da, 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 da. It is two things. It is a book. It is the Collins Stargazing Beginner's Guide to Astronomy, and also a Collins planisphere. If you don't know what a planisphere is, it's a disk that you set the date and time around the outside of the disk, and it shows you from the latitude that you're at. And this one is for use in the UK and Ireland, Northern Europe and Canada. So I'm afraid our American viewers won't be able to make much use of this. But basically, you set the date and time around the edge, and it shows you at the time what is visible in the sky or any day of the year. And planispheres are very, very useful things to have when you're starting out in astronomy. So that's the prize. As you can see, it's a beginner's guide and a planisphere, which is a sort of a beginner's tool for astronomy. So we're not going to make it very difficult this week. We're going to do, or this month, we're going to do a competition which is really aimed at people starting out in astronomy. And to keep it really simple this month, what we've decided to do is this. We're going to just hold a draw for these prizes. What do you need to do? We're going to ask you a simple question, and what you need to do is write the answer in an email and mail it to us at spaceodditieslive@gmail.com. And just to repeat that, that's spaceodditieslive@gmail.com. And we will simply pull a reader's name out of a hat or a space helmet or whatever we've got around. So your question to answer to win those lovely prizes of the Collins Beginner's Guide to Astronomy and the lovely planisphere is this. How long to the nearest minute does it take light to travel from the sun to the Earth? How long to the nearest minute does it take light to travel from the sun to the Earth? Pop the answer in an email, send it to spaceodditieslive@gmail.com, and you could win those wonderful prizes. Now, we're going to set a closing date because all you have to do is send an email, which we don't think should take you very long. We're going to set a closing date of next Monday. So we will be announcing the winner on next Monday's show. So if you could get your email to us by the end of Sunday, that would be much appreciated. So we're going to say midnight on Sunday, this coming Sunday, as the deadline for the competition. Just to say that again, how long does it take light to get from the sun to the Earth to the nearest minute? Pop the answer in an email, send it to spaceodditieslive@gmail.com, and we will pull one of the lucky winners' names out of a hat or whatever we have available. So there we are. So that's this month's competition. Nice and simple this month. You don't have to write anything. You don't have to draw or paint anything. Just answer that simple question. Okay, we're going to move on now. And we're going to move to the man who is on my... It's difficult to say, really. I guess it's my right, actually. He's over there. So we're going to come to Roger. And Roger is going to, rather expertly, as he always does, give us his guide to the night sky for this part of February. So, Roger, what's going on?
Right. What is going on? That's the big question. So, for the 20th to the 26th of February 2023, we currently are experiencing a new moon at the moment. So, things will probably be looking better in the night sky if you've got clear skies, which I currently don't have. That's getting a bit boring now.
I've got exactly that. I've got Jupiter and Venus beautifully in the sky this evening.
And this is, well, I've got a picture of to remind me what it looked like yesterday, and this is what it was currently like during about tea time yesterday. So they are certainly well observable objects in the evening sky. So
in the west, that is,
yeah, and it's no problem at all. This is what the sun looked like yesterday. I haven't got one today, it was too cloudy. So we are getting some sunspots popping up, and there are some more turning around from the eastern limb. So that's good.
Nice.
It's not let us down yet, as it's still coming up to its maximum. So there we go. And during last night, I saw Kevin Earp's picture and I thought, oh, I'll have a quick go at that. And unfortunately, it was only a quick go because it clouded over later. So I've only got an hour's worth of data here. So
Oh, the pain.
yes, the pain. So that's
It
all
looks,
I could manage for an hour, I'm afraid, in my bottle 4 Sky garden.
yeah, it looks rubbish, Roger.
I know,
Yeah,
it's
that's
terrible.
awful.
I
That's
don't
all.
know.
A child of 5 could do better, to be quite honest.
Yeah, I can draw better than that, but there we are.
Now that's a magnificent image.
It's
It
not
captures both of them really well, doesn't it?
Mm-hmm.
Beautiful.
And if you were able to see it as clear as me, you see some some satellite trails going through it as well. But we won't talk about that.
The satellite trails. I mean, I probably asked you this before, Richard. Do you actually do anything with your images? Do you frame them and put them on the wall and things like this? As
No.
I would.
Yeah, no, I haven't.
Oh, you should.
Not yet. Maybe.
You should do. Seriously, you must have a church hall locally. Why don't you ask them if you can do an exhibition of your artwork? Print them out big, put them in frames, sell them for 50 quid a pop. You do really well.
Well, see about that then.
Yeah.
Okay. Right.
I want commission.
Okay. 25%.
Yeah, anything will do really. I don't care.
Right, okay, so we've still got Comet C 2022 E3 ZTF. It's now coming past the bow of Orion, the hunter, and is now descending more rapidly as the weeks and months progress. So it won't be with us too much longer, but then by that time it'll probably be a lot fainter. But it's still on the go, no problem there. So if you're still interested, there's still something to see.
Yeah, I managed to see it for the first time last week.
Did you?
Yeah, the sky was finally cleared up, and I finally got some time. Took my binoculars, and I saw it was it was quite blurry, but still I knew where to look, and I was quite pleased to have seen it before it goes.
It's still moving through the night sky at a reasonable pace in regards to the background of the night sky. So if you spot it one night, just look a bit lower down as it's heading southerly now to the other constellations.
Yeah, and we hope that our viewers, many of our viewers, have been able to see it as well. Actually,
yeah. And this was last week when it was going past Aldebaran. One of my little images. There's no visible ion tail on there, but there is a bit of a tail there. But that's all I could. That's all I could image. So that's a single. That's just one single frame. That image.
Amazing.
Yeah, nice.
That's not a composite or anything. That's just a single frame.
Just a single frame. Yeah.
Andy, I was going to ask, have you been able to see it?
No. No, I haven't. I haven't had a lot of time to go out and look for it. When it was in the more in the northern sky, it was obscured by the light pollution from Girona to the north of us. And I actually don't own a pair of binoculars. This is
you should have entered the competition.
Yeah, I know, under a pseudonym or under another name, whichever. So I need to get some binoculars because, with my telescope, just pointing it to roughly where I think it is, I could be there forever. And because my telescope's getting on in years, I can't connect it to the internet anymore and download the ephemeris for the comet, which I used to be able to do for comets. Just download it from the internet, and the telescope will find it automatically. But it's not doing that anymore because the computer's given up. So no, I haven't had, but I'm not incredibly sad about it because yes, it's always lovely to see a comet, but I'm sure there'll be much brighter, more visible ones along before too long. So it's just one of those things. I'd be lucky to see another Hale Bopp in my lifetime, obviously, but you never know. That's the thing about comets. You never know when a bright comet is going to
Well, I'm just about to go on to another comet, Andy.
Oh, right. Go on then.
So
Pandoras comet, yes.
Yeah, but we've also got Comet 2022 A2 Pan Stars, which is going through Cygnus at the moment. And although that is a couple of magnitudes lighter. It's magnitude 9.7. So
Right.
you will need a telescope to image it, but
Yes.
it is currently moving through Cygnus at the moment. And as you
Right.
can see, it's going, well, in the sort of northeast westerly part of Cygnus at the moment. But
But this one is even smaller than the other one, isn't it?
yeah, but you know,
Yeah.
if
Yeah.
you're feeling that you need to go comet spotting, then this is just an illustration that there are many more other ones about. But
Sure.
these are
Sure.
one of the brighter of the fainter ones, if you see what I mean.
Yes. Absolutely.
What-
Thank you, Roger.
Can I ask, do you know what type of comet is this one? Is it like a one that comes from the Oort cloud, or a more regular one?
Well, I think this one's got a more shorter period, obviously, than the last one. Obviously, but
Okay.
I haven't got any precise information regarding its origination, its orbital period, and stuff. I could find out, but at the moment, I know nothing, and I'm not from Barcelona.
I know nothing. I know
No.
nothing.
Okay,
That's fine.
so meanwhile, in the night sky, we have at 10 p.m. we are now seeing Orion slowly setting towards the western horizons, and the huge constellations of Leo and Virgo, with all those galaxies, are now making their appearance towards the heading up towards the spring summer constellations that we are now will be experiencing. And yeah, so basically once Venus and Saturn are set, you've only got Uranus, if you can spot it, and Mars really of interest there to study if you're interplanetary. But even Mars is getting quite small now. It's around about 10 arc seconds now, so I'm afraid it's going to be looking at galaxies now, I'm afraid, if you're into deep sky objects.
Fantastic. It's that wonderful time of year, all the spring galaxies.
But then we'll be getting the Milky Way and the galaxy, the core coming up soon in the next month or so. So we'll be able to get some good panoramic views of the Milky Way spanning through the night sky. So that would be of interest.
Absolutely.
And as you can see, right. So we do have some images from the James Webb. This one is called Pandoras Cluster.
That is
pretty much everything is a galaxy.
Yeah.
Galaxies, absolutely flipping everywhere.
Wow.
Absolutely amazing.
What do we know what's the exposure time for this picture?
That one was quite short, if I remember rightly. I think it was. I could look it up, but yeah, it was quite short. It wasn't. Do you remember the SMACS 273 image, the first one with all the gravitational lensing in it?
Yeah.
That was a prolonged, many hours exposure. For some reason, I have it in my head that this one was actually quite short.
I think the first one was 12 hours.
12, wasn't it? Something like that.
Yeah.
It's four images stitched together. They're between 4 and 6 hours long. And I think they add up to 60 hours. I could be wrong on the total, but it's
right.
But they add up to 60 hours altogether.
Wow.
So so somebody's just asked the question: why are some of the galaxies? It's Graham Turvey. Why are some of the galaxies red?
Well, believe it or not, Graham, some of them are red. And it's an indication of the elements that predominate in the galaxy, and it indicates. Let me see if I can get this right. What does it indicate? It's basically either a lack it's a lack of helium. Is it something? I think it's a lack of one of the elements in the galaxies that, by the time the light reaches us, it looks red. It's not redshift. Redshift is actually pretty much undetectable to the human eye unless you get right towards the edge of the visible universe. It's to do with the elements in the galaxy and the rate of star formation, and the proportions of each element in the galaxy. Sorry, I can't be more succinct than that, Graham. But it's to do with the constituent gas of the galaxies, and they are known as the red galaxies. They are physically red as against them being an effective redshift.
So, Andy, so how do you differentiate those in regards to redshift galaxies, which are red because of their distance and because they're moving
because
away?
when you get out towards the edge of the observable universe, let's say 12 billion light years ago, 12 billion years ago or more, the galaxies are much more in a nascent, irregular blob form rather than well-defined spirals. So they actually look physically different from the galaxies that we see here, which you can tell are they're obviously huge distances away, but they are still pretty much local, if you like. So there we are.
Right. Okay. So here we have some more galaxy images. NGC 1365, which is in the constellation of Fornax. So most of these images seem to be in the southern hemispheres from what we've.
That's yeah. Listen, I think that's dreadful. That's hemispherist. It's discrimination against those of us in the northern hemisphere. Yes. Definitely.
Mm-hmm.
So we've got the comet.
Yeah, that's true. That's true.
Okay, and then we've got NGC 1433, which is in Herodium.
Oh, another southern one.
Yes.
Isn't that? And if you look, remember above all else, this is an infrared image. So it's not how the galaxy would appear to your eyes.
No.
Invisible light, it looks very different. So what the Webb is doing with these galaxies is enabling us to see the sort of the networks of gas and dust within these galaxies that is totally, more or less invisible in invisible light. So by looking at the galaxies in the infrared, we can see the fine structure without the light of the stars obscuring it. It's fascinating. I mean, look at that structure in the galaxies. So all spiral galaxies, basically, under the hood, if you like, look like this: a fine, very fine network of gas and dust. Amazing.
Okay, so we've also got this one, which is in the constellation of Grus.
Oh, Grus. Not one I'm familiar with.
No.
Interesting.
Again, but we're seeing the same thing. We're seeing the dust and the gas, and the fine structure there. It's sort of, if you like, the superstructure of the galaxy. Although we should say, of course, the real superstructure of the galaxy is dark matter, but this is the next level up, if you like, in terms of structure. Amazing images from the Webb telescope.
Yes.
You can really see the massive dust there on the top left.
You can, can't you? Yeah.
Quite remarkable.
Truly amazing. Truly amazing. And that's there's a scale there. Look, 3,500 light years at the bottom right.
Yeah.
It's amazing.
So there we are. There's some interesting images.
Thank you, Roger. Out of reference, what's the diameter of our Milky Way again? Thanks. Okay, guys.
Sorry, I missed that. What was the question?
Breaking up.
Out of
our galaxy is about 100,000 light years across.
Yeah. Okay. Yeah. So out of reference, that's quite a small galaxy.
Yeah. Absolutely.
Our colleague Steve Warbis, when we were talking about red stars, and it's along the same lines as you said, Andy. He says, is it that older stars / galaxies have lower metallicity and tend to be redder?
No, because the number of red galaxies compared to all the galaxies is actually very low. They haven't found that many of them. Obviously, they've just found a few more with the Webb telescope. But up until now, they're actually been quite rare. So we know of galaxies that have got the same metallicity, and they're not red, Steve. So I don't think it's anything to do with the metallicity. But guys, just chat amongst yourself for 2 minutes. I'm just going to look this up. So
Yeah.
Jack, thanks for letting us know that you have already responded to our competition. So that
Yeah, I've got it here. It's arrived, so it'll
Good.
go in the hat if it's right.
Thank you for that.
Also, there's a question here: do all galaxies rotate in the same direction? I think the answer to that is no.
no, they don't.
Could be wrong.
Well, it
No,
depends on your
they
frame of reference, right?
well, yeah, but even if they're rotating differently, no matter what your frame of reference will be, you will see that the against the other galaxies they will still be rotating differently.
Sure.
Because they seem to think that with some of the spiral arms they rotate against the direction, and they think that funnels gas into the center, where it can either form new stars or be absorbed by the black hole at the center. Because also galaxies are, as we all know, are also moving through the interstellar medium, and you get something called jellyfish galaxies, which are fascinating things when you see pictures of them. And what they're doing is they're moving like that through the interstellar space, but off the back you get all this stream of gas and dust left behind, which is then irradiated by the stars in the galaxy, and you get this sort of like jellyfish effect. So yeah, galaxies are interesting animals, and I think there's some news in the news. There's another little story about galaxies, so we'll leave any other information about galaxies till we actually get to the news section. So
yeah,
they're
apparently,
interesting.
apparently the reason they're red is because simply they contain an awful lot of dust, and the dust reddens the light from them. So it's dust that's the governing
Fascinating,
factor
isn't it?
in those galaxies. Or well, it's not actually fully understood, or it may be a function of the ages of the stellar populations in the galaxy. So the galaxies consist of mainly older stars, which are redder than obviously the blue white brilliance of younger stars on the main sequence. So it could be a combination of both, but it's either going to be a lot of dust in the galaxy that reddens its light, or it's going to be because of the age of the population of stars that it has. So there we are. Interesting, eh?
Also, Steve says the width of the Milky Way galaxy is 100. I think that's 100,000 light years.
Yeah, that's yeah. Thanks, Steve.
Yeah,
That's what I thought. Yeah. Okay.
Yeah,
So
but just one thing with Roger, I'd just like to remind people from something we mentioned last week. We saw a couple of pictures there of Orion. It's still not too late to join the the campaign to protect rural England, or CPR, their star count. It's ongoing at the moment. It
Yeah. Is that
started
to the
last Friday.
24th there, Dad?
Yeah, 17th to the 24th. You can still join and get out there, count the stars in your area. And as we said, you'll be doing citizen science. When you put your answer in, it will go to actually develop a map showing the light pollution in the UK, which is something that as we said last week, it's a fight we're actually losing. So yeah, it's so just get online to just look for the CPRE star count, and that will take you directly there. Just sign up, clear night, get yourselves out there, let your eyes adapt, and then see how many stars you can count in the asterism of Orion. There's also lots of stuff on there for the children to do, for the adults to do. Lots of information about starting stargazing. It's really worth even just if you want to just go and have a look about how to start stargazing and things like that. So I just thought I'd pop that in there, seeing as Roger had Orion popped up there. So yeah, thank you.
yes, okay. Well, viewers, as you may notice on the screen, if you would like to support us in our efforts to Space Oddities, we absolutely live on coffee. And if you want to buy us a coffee, or at least one each, we'd really appreciate one each, because it's a bit difficult to put that cup in the post to send it between countries. So if you'd like to buy us a coffee, and it's no more than the cost of that, whatever you want to pay for it, scan the QR code, and that will take you to the page where you can make a payment for buying us a coffee. I'll just leave that up there for a couple of minutes, obscuring Bernard and Daz's face, which is probably a good move at this point in the evening. Let's just see if I can just... oh, yes. Oh, I've still obscured Daz. Now it's coming from Roger. So there we are. So there we are. Anyway, yes, we running Space Oddities and bringing you our content week on week is not free. We do have to pay various things. So, the cost of a cup of coffee will be much appreciated, and we shall drink it with much relish and savour every last drop and think of you while we're drinking it. So thank you very much for that.
And,
okay.
Can I just say, and while you're doing that, viewer, don't forget to like and subscribe to the channel, please.
Absolutely.
Share it
Well
with your
said,
friends.
Bernard. We would like to keep growing the channel. We've got plans on what we want to do, but a lot of it depends on having more viewers to make it worthwhile us doing it. So if you would like us to expand Space Oddities and do bigger and better things in the future, and we have got a few plans, like and subscribe. I'm very happy to tell you that the vast majority of people who do watch us live have actually subscribed, but we've still got about 23% of people who watch us who haven't subscribed. The shame. And, just hit the subscribe button. It doesn't cost anything, and it enables us to grow our audience. It enables YouTube to see us. It makes us more visible to YouTube. And that in turn will lead to bigger and better things for the channel. So thank you all very much for your support. Those of you that are here every week, we especially appreciate you, but we still need coffee. So do consider buying us a coffee.
If you subscribe and hit those notifications.
And I can see a couple of you have scanned that already. So thank you very much for doing that. Much appreciated. And there we are. Right. I'll probably bring that up towards the end of the show again. So we'll get rid of it for now. But now we're going to move on to this week's news. So here is this week's news. So this is something that I was quite amazed at. It's a high-resolution radar image of the moon taken from the Earth, and in stunning detail. And I'll just read you the story behind it. Taking high-resolution radar images from Earth is what a collaborative team of scientists and engineers from the National Radio Astronomy Observatory, or NRAO, Green Bank Observatory, GBO, and Raytheon Intelligence and Space, RAS, lovely lot of acronyms there for you, have set out to do with the National Science Foundation's Green Bank Telescope and the Very Long Baseline Array, or VLBA. Through their efforts, the GBT, which is currently the world's largest fully steerable radio telescope, could be home to a next-generation high-power planetary radar system for scientists to use to study the planets, moons, and even asteroids within our own solar system. The prototype radar consists of a low-power transmitter that was developed by RAS, tested using the GBT, and targeted at the lunar surface, with the radar signals bouncing back and being received by NRAO's 10-25-meter VLBA antennas. What's most remarkable about the transmitter is that it only produces up to 700 watts of power, which is less than a standard microwave oven, at 13.9 gigahertz. The prototype radar was able to image the Tycho crater, which, as you probably know, is that prominent crater that you can see towards the south pole of the moon when the moon is full, with those lovely white rays spreading out from it. The crater is approximately 85 kilometers in diameter. And the radar managed to achieve a resolution of 5 meters, revealing these incredible details of the crater's floor. And let's just have a look at that image in a bit more detail. That's the image. And, as you can see, the detail is quite stunning.
Yeah, really impressive.
I'm afraid there's another leaking Russian capsule. Roscosmos appears to be having some issues with the spacecraft again. in December, the Soyuz MS-22 spacecraft, you may remember, had a leak in its coolant loop, which resulted in it spewing out coolant like a snowstorm into the vacuum of space. And now there's another problem. And there's another module, another Soyuz, that has developed a fault. They noticed it was it wasn't a Soyuz, it was a Progress, the freighter, if you like, that carries supplies up to the space station. And Mission Control Center outside Moscow recorded a depressurization in Progress 82, which is currently docked with the Pulse laboratory module. The cause of these leaks remains unknown. There are suspicions with the first leak that it was caused by a micrometeorite, but now scientists aren't so sure. It could possibly be some sort of general fabrication error with Russian spacecraft, which is a bit worrying, really. But they're investigating. According to the latest update, the crew has returned to normal space operations and research. The hatches between Progress 82 and the station are open, and temperatures and pressures are normal. Officials continue to monitor all of the space station systems and have not reported any other issues since. But what this means is that the launch of Soyuz MS-23, a replacement spacecraft for the Soyuz that leaked, was due to launch on February the 19th. It's now been delayed. And it was going to bring NASA astronaut Frank Rubio and Roscosmos astronaut Sergei Prokofiev and Dmitry Petelin. And it was going to bring them home. That has now been delayed. And we don't know when that's going to happen next. Now, another meteoroid has been discovered before it hits the atmosphere. I think we mentioned, excuse me, I think we actually mentioned this on last week's program because it happened last Monday. And it ploughed into the English Channel, and it was detected just a few hours beforehand, and skywatchers were able to capture the event. Astronomer Christian Sarneski found the 1 meter asteroid just half a day before it came through the atmosphere. He used the 60 meter Schmidt telescope at the Piseskit, sorry for my pronunciation if there are any Hungarian viewers watching, observatory in Hungary, and originally named it SAR 2667, and then it was renamed 2023 CX1. And he predicted with 100% certainty that it was going to hit the skies above the English Channel. Astronomers continued to track it, which then blazed through the atmosphere over Europe right on schedule. And as you can see from this video, or this animation, it was quite spectacular. And even our own Mary from Space Oddities managed to capture the flash of it on the camera from where she is in Oxfordshire. So that was quite an achievement as well. But the best thing about this is they've actually found a chunk of it. And there it is. According to the International Meteor Organization, it mostly broke up in the atmosphere. Let's see if we can just make that a bit bigger for you. There we are. And an 18-year-old called Louis Leblanc, who was part of a French search team, found it after his attention was caught by a dark stone barely level with the ground of a field in the town of Saint-Pierre-le-Vigier. The IMO has calculated the range where the meteorites would have dropped. The strewn field would have been centered on the towns of Angers and Huturt. The IMO said that probably only one large piece of a mass of about 3 kilograms emerged and could have later landed as a roughly 2 kilogram meteor. And they also said, we guess that an uncertain number of small meteorites of masses up to several tens of grams, which originated in the meteor, could land as well. So they're still hunting for bits. But there you see the chunk that was found. And Louis Leblanc is a very lucky person because that's a once-in-a-lifetime find. Well, perhaps you'll find more. Let's hope so. But you don't find meteorites like that just laying on the surface very often. So that was quite a nice event there. Moving on, a galaxy has been found that's almost entirely dark matter. Astronomers have discovered a galaxy with very little or no stellar mass. Dragonfly 44, as it's called, is about as massive as the Milky Way, but it's only 1% as luminous. Galaxies like this are called dark galaxies. It contains clouds of gas but very few stars, possibly none. This is the only isolated dark dwarf galaxy in the local universe. All galaxies are made up of mostly dark matter. The visible matter, like stars, gas and dust, make up only a small percentage of a galaxy's mass. But galaxies like this one, which is actually named technically faster and numbers, lots of numbers, are even more extreme. And its low luminosity suggests there are no stars, only clouds of gas. The astronomers who discover it say the galaxy is without any optical counterpart, so it's pretty much invisible. Astronomers found the new dark galaxy with the 500-meter aperture spherical radio telescope FAST, which is the biggest radio telescope in the world in China, and the panoramic survey telescope and rapid response system PanSTARRS, which we mentioned earlier in connection with the comet that the PanSTARRS also discovered. It's a newly discovered galaxy and appears in most ways to be a typical disk galaxy, but it's got an extremely low magnitude and low stellar mass. So there we are. So these galaxies do exist that are almost entirely dark matter. So that's really interesting. And astronomers have also spotted a rogue supermassive black hole. These, of course, lurk in the center of most large galaxies like ours. From their commanding position in the galaxy's heart, they feed on gas, dust, stars, and anything else that strays too close, growing more massive as time passes. But in rare circumstances, a supermassive black hole can be forced out of its position and hurtle through space as a rogue supermassive black hole. In a new paper, researchers from Canada, Australia, and the USA present evidence of a rogue supermassive black hole that's tearing through space and interacting with the circumgalactic medium. Along the way, the giant is creating shock waves and triggering star formation. So it's compressing gas as it moves around the galaxy that it was ejected from, and the compressed gas is giving rise to stars. Rogue SMBHs are the results of when galaxies merge. It leads to the formation of a binary supermassive black hole at the center of the merger remnant when two galaxies merge. The binary supermassive black hole can be very long-lived, surviving for as long as 1 billion years before merging. If during that time a third supermassive black hole reaches the galactic center from a third galaxy merging with the previous two, then you've got the old three-body problem, and an interaction between the three black holes can actually give one of those supermassive black holes a kick, which kicks it out of its galaxy. So they found evidence of one of those. Not many of these have been found. This is not the first I seem to remember. There have been a couple, but obviously this is not something that happens very often, because you need three galaxies merging for that three-body problem to cause one of the supermassive black holes to get kicked out of the galaxy.
Can I just say, it's a scary world out there.
Yes, isn't it?
Supermassive black hole going rogue.
Yeah, absolutely. And these are events that the scale of which is just beyond our comprehension. So, good news. The European Space Agency is building an early warning system for dangerous asteroids. They're working on a new mission that would act as an early warning system for dangerous, hard-to-see asteroids called NEOMER, which stands for Near Earth Object Mission in the Infrared. So it's an infrared observatory. The spacecraft would orbit between the Earth and the Sun at, guess where, the L1 Lagrange point, finding space rocks that otherwise get lost in the glare of the Sun. The ESA says that NEOMER will monitor a close ring around the Sun, a region that's impossible to observe from telescopes on Earth because of the Sun's glare. By making observations in the infrared, NEOMER will detect the heat emitted by asteroids themselves, which isn't drowned out by sunlight. Additionally, this particular range of thermal emissions are absorbed by the Earth's atmosphere, another reason why an Earth-based telescope wouldn't fit the bill. Also, as a space-based observatory, NEOMER will be able to see closer to the Sun than we can currently see from the ground. Asteroids in that region that are 20 meters and larger and heading towards the Earth should be detected by NEOMER at least 3 weeks in advance, so that would give us some time. In the worst case scenario, in which the asteroid is spotted passing near the spacecraft, we would get a minimum of 3 days warning, the fastest the asteroid could move from L1 to the Earth. So this is good news from the European Space Agency, that they're putting this telescope at the L1 point to look out for these asteroids, which would normally be lost in the glare of the Sun. So that's good news. It's more safety for us, of course. Okay, this is an interesting concept. This is a new paper that's come out suggesting that black holes are the source of dark energy. In a series of papers, an international team of researchers led by the University of Hawaii reported that black holes in ancient and dormant galaxies were growing more than expected. This constitutes, they claim, the first evidence that black holes could be the source of dark energy. In their papers, the team led by Duncan Farrar, an astronomer with the University of Hawaii at Manoa and a former PhD with Imperial College London, report the first observational evidence that black holes gain mass in a way consistent with them containing vacuum energy. Whereas astrophysicists have been looking for a theoretical resolution to the problem of dark energy in black holes, the team's findings allegedly constitute the first observational evidence that black holes are the source of dark energy. Now, vacuum energy is this weird energy that's inherent in the fabric of space-time. So in any given volume of space that looks empty, that you don't seem to be able to measure any energy in, vacuum energy is built into the sort of the quantum realm of space-time and is thought to be possibly an enormous amount. If true, the finding removes the need for singularities to form at the center of black holes, resolving a long-standing debate. It also means that nothing more is needed, no new forces or modified theories of gravity for our cosmological models to make sense. Dr. Chris Pearson, a researcher from RAL Space, a research council overseen by the UK Science and Technology Facilities Council, or STFC, and Dr. Dave Clements of the Department of Physics at Imperial College were co-authors on the paper. So this is something really strange that's suggesting that if you can get your head around this, that as the universe expands, the mass of black holes actually increases. They're linked together, and black holes, if you like, are factories for this vacuum energy that somehow come out of the black hole and force the expansion of the universe to accelerate. It's all a bit weird, to be quite honest, and many scientists quite rightfully skeptical. So there you are, guys. So that is that's the news for this week.
Ooh. Okay. And did ask, she's popped off the top. Well, I just see it. Do you know anything about the discoveries of auroras on the moons of Jupiter, suggesting the presence of oxygen? Now, this is with a new thing that's just come out. I think I read it in. It's disappeared now. I think I read it in the magazines this time. But I know they have detected auroras off to the moons, and she was wondering whether or not it was a proof of oxygen in the atmosphere.
No.
Pete Bernard had one too.
No, it's auroras really have little to do with the presence of oxygen. They are caused when charged particles from the sun interact with the magnetic fields of planets like the Earth and these moons. And what Daz said is quite right. Astronomers have now detected aurorae on 3 out of 4 of the Jupiter and Galilean moons, Io, Ganymede, and Europa, Ganymede, and Callisto. And previously, they'd only really seen them around Jupiter itself, but now they've detected aurorae. So this is to do with charged particles of the sun interacting with magnetic fields, and doesn't say anything about the presence of elements. Having said that, of course, if you look at aurorae on the Earth, their colours can be due to the presence of various elements like oxygen. But in this case, we know there's no oxygen because those moons have absolutely minimal atmospheres, if any. So there you are. But thank you very much for your question. So there we are. Now, Bernard, I know you have to leave promptly at 9 today, so I think now's the time to show us your wonderful presentation.
Yeah, sure. No, and I just wanted to add on what we've discussed about auroras on the icy moons of Jupiter. I replied to Anne, and we have been detecting auroras around Ganymede, and that was one of the proof that there is a subsurface ocean underneath
that's
it.
true, yes.
But that was the only one that was detected, and so maybe the auroras that we have detected around Europa and Callisto are another line of evidence for subsurface oceans around that. That's really interesting. And I just wanted to also remind our viewers that there's always a little bit of oxygen in those tenuous atmospheres, because surface ice gets broken up with the radiation into hydrogen and oxygen.
But these atmospheres are incredibly thin.
Oh yeah, tenuous.
Yeah.
Yeah, absolutely,
Yeah.
absolutely.
Yeah.
We're talking about, you
Process.
know,
Mhm.
1% of the atmosphere of Earth. So yeah,
Yeah,
really small.
absolutely.
The process is called photochemistry. It's radiation from the sun breaking up the water molecules into hydrogen and
Yeah.
oxygen. So you do get a very thin layer of oxygen in there. So yeah, it's just one of those things.
Yeah.
Mm.
Yeah, so I'm going to do a presentation tonight on something I took my daughter to see in the town near to where we live, and it was absolutely fascinating. And it's about viewing the sun in a different way, in a much more dramatic fashion, I'd say. And I just wanted to just quickly show that to you folks in case that exhibition comes to your town. I highly recommend it. So basically, the idea is you get to see the sun through videos that were taken by NASA Solar Dynamic Observatory, which is, I'm going to show you, it's a probe that's currently observing the sun. And we're seeing that in 3D. So the idea come from this lovely gentleman called Robert Walsh, which I met over when I went to see this exhibition. He's a professor of solar physics at the University of Central Lancashire. He's a really nice guy. And the idea came out from when they were doing illuminations in Blackpool. I have never been, but apparently you have yearly some huge big illuminations at the Blackpool.
Absolutely, very famous ones.
Yes, city in the northwest of the UK, and apparently during those illuminations, one person, I think Robert, said like, why don't we try and use illuminations to actually do science outreach programs in relation to the sun? And so he teamed up with other people, and basically what they did is that they took live footages of the Solar Dynamic Observatory. The Solar Dynamic Observatory is a space probe that was launched in 2010, and it's still viewing the sun as of now. It's orbiting the Earth, but it takes wide-angle images of the sun in multiple wavelengths, and here's some examples of it. And of course, you know, depending on which wavelength you look at the sun, you are going to be able to look at different regions, either the photosphere or the chromosphere, whatnot. And thanks to these different instruments, it manages to this space probe, sorry, not space probe, observatory, solar observatory into space, manages to capture simultaneously the sun through all these different wavelengths, which is absolutely amazing. And basically what they do after with these images is that they make this huge, massive sphere, and then they just display on the sphere live images that was taken by SDO in 2015, and that was at one of the height of the solar prominence. And they display it on the sun, and so as this big sphere rotates, or at least the image that's projected on the sphere rotates, you actually see the prominences, you know, being created and going into their explosive phases and die down. And these are some of my pictures. This is a picture of my daughter in front of it while the sphere was on, and you can see that this huge, massive sphere actually displays all these different wavelengths that SDO has taken. So again, these are live images. These are, of course, static images, but like live video shots. So all these images are actually moving on the sun itself. And
Amazing.
yeah, it's stunning. It's absolutely stunning. These are the pictures that are taken from the website of this science project. So you see, it's been going around various cities in the UK. It's been to Brussels. It's been to various cities in Europe, and it's just jaw-dropping. So I recommend anyone who is interested. The project is called seethesun.org. This is their website. Go on the website, have a look, and see whether they come near you, because this is definitely something that you need to take your kids, or actually just to go on your own and get to meet Robert, because he was there and some of the other people were involved with this project. There's an artist from London. There was also a project manager, but unfortunately I can't remember the name. So this is absolutely fascinating, and my daughter was completely amazed, and it was just, you just get to see the astronomy in a completely different light, and no pun intended. It's really just, it's one thing to look at images and videos and read books, but then when you see something in 3D like that, and you see
it's and for kids it's wonderful, isn't it?
Yes,
because rather than seeing something flat and two-dimensional in a book or in a video, they can just get a much better idea of oh, that's a lovely photo. Look at that.
Isn't it?
Yeah.
Yes.
They can get a much better idea of what our sun actually looks like on its shape.
Yeah, and so definitely check it out. They don't.
Sorry, Bernard. I didn't hear if you said, where was this?
Oh, this was in the Steam Museum in Swindon, in North
Steam
Wiltshire.
Museum in Swindon, right? Yes.
Yeah, in North Wiltshire. So I don't know where they're going next. I looked into the website. I couldn't see their program, their tour program. So you might want to reach out to these people and contact them.
I doubt they'll ever come to Spain, but who knows?
Well, no, they've been to Brussels. They spent 3 weeks.
Have they really?
In Brussels.
Yes.
Yes.
Right.
Yes, and
I'll have a look. Thank you. I'd love to take Chloe to see that. She would love that.
I think they come on upon invitation. Various cities have budgets for science outreach events and
sure,
like so,
sure.
So
yeah, there we are.
Those programs.
Well, that's wonderful, Bernard. Thank you so much for.
Just to say, I've just had a look on the website, and in July this year, they're at the Daresbury Open Week, Daresbury Laboratory in Warrington.
Oh, well, there you go.
There we are.
And in September, they'll be at the Orkney International Science Festival at Kirkwall. So that's up in Scotland.
Oh, right. No mention of Catalonia in Spain, unfortunately.
No.
I didn't think so. Worth a try, though.
Thanks, Roger.
Yeah.
Okay.
Thanks, Rother. That's cool. No, definitely, guys, go and see this. It's definitely worth it.
Yeah, definitely. Okay, then. Well, I think that just about brings us to. I love this. The power. All right. I'll get rid of it. So there are. Listen, thank you so much to those of you who have bought us coffees this evening. It's so kind of you to do that. We do appreciate it. Daz, you wanted to say something?
Yeah, just a quick one. Earlier on, I mentioned jellyfish galaxies. Now, if you go onto Galaxies Zoo, there is actually a project running there where you can identify and mark up the directions and the length of the tails of these galaxies. It's citizen science. You'll be helping the scientists to mark out and find these galaxies. There's a full tutorial how to do it. It's so simple. Just go to Galaxy Zoo, look up for jellyfish galaxies, and they will tell you what to do. And then you can just sit there. You can take your time. You can either do one or two, or you can sit there all afternoon and do them. And they'll give you images. You look for the jellyfish galaxies, and they are quite distinct. And then you just follow what the instructions tell you to do. So Galaxy Zoo, absolutely fantastic place. Get involved, and you'll see these jellyfish galaxies for yourself. And there are quite a few of them.
And just as an idea, guys, perhaps we could do a program on citizen science and look at our famous projects there, because I do quite a few projects on Galaxy Zoo.
Juno's amazing with that.
Yeah, absolutely. And I do the original galaxy classification. Hunting for exoplanets, which you can also do, find exoplanets. Yeah. If you remember back in the days of Stargazing Live on the BBC, which for some peculiar reason the BBC cancelled, even though it was getting good figures, moan, groan, they invited people live on the programme to find exoplanets, and one of the viewers actually did find an exoplanet. So there we are. We'll say goodnight at this point to Bernard, who is leaving us. Bernard, look after your lovely daughter. Of course you will. And keep showing her wonderful things about the universe.
Thank you. Sorry, folks. I have to drop out.
Yeah, thank you for your presentation. Hopefully we'll see you next week.
Yes.
Bye,
Thank you for
Bernard.
the coffee, everyone. Thank you for the viewers. Bye bye.
Yeah. Bye, Bernard. Yeah, he's going. Oh, thank God he's gone. Oh, sorry.
Right.
So anyway, yes, to answer Graham, who said earlier, perhaps we need a Galaxy special episode. We could do an episode all about galaxies. What are galaxies? What the different types of galaxies, etc. Thank you for the suggestion, Graham. It's very kind of you. And there we are. So the hour is upon us. Not that we have to stop now, but we will leave you for now. We'd like to thank each and every one of you for being here. Thank you very much. It's been an interesting evening as always for us. So thank you for your chat. Thank you for your support as ever. And again, thank you for those of you who have bought us coffee this evening. And we will see you back here next week on Space Odysseys. So my thanks to Roger for his superb night sky guide as always. Thank you to Daz for just taking his mind off Bruce Willis for an hour. And we will see you back on Space Oddities this time next week. Don't forget, you can find us on Facebook. Do join our Facebook group. We are facebook.com/groups/Space Oddities. I'll just say that again with my teeth in. Facebook.com/groups/Space Oddities. And we'd like to thank our sponsor, Rother Valley Optics, for supporting us in our endeavours to bring the universe to you every Monday, because we love doing it and for no other reason. And we're happy that you like what we do as well.
Competition. Don't forget the competition.
Don't forget, yes, thank you, Daz. I nearly forgot that. Don't forget the competition. Answer the question: how long to the nearest minute does it take light to travel from the sun to the Earth? Put that answer in an email. Send it to spaceodditieslive@gmail.com, and you will be entered into the draw for the Collins Beginner's Guide to Astronomy and that lovely Collins Planisphere, both of which are well worth having. So we will say tonight, finally, good night to all you. Have a fantastic week. Thank you for being here, and we'll see you again next week. Bye-bye.